The solar system is unique. There is no other like it in the universe. It differs from all other planetary systems and has signs of artificial origin. Such or approximately such information is now flying at us from the screens of computers, smartphones, yes, from everywhere. And it doesn't matter whether you're listening to an alternative channel or classic science pop, it's roughly the same everywhere, just with a different sauce. For example, there is a prevailing opinion now that planets around other stars are arranged differently. The heaviest and most massive planets, like our Saturn or Jupiter, are close to the stars, while smaller planets like Earth or Mars are, on the contrary, thrown to the edges of the systems. This has already spawned numerous hypotheses about the solar system's artificiality. Hello with you, Channel Epoch of Mistrust. And now we will try to figure it out with just one planet, Mars. But as it turned out, whether we want it or not, we will have to start from very far away. In recent years, there has been a whole surge in the discovery of new exoplanets. That is, planets orbiting other stars. And in most cases, these are massive and supermassive planets, comparable in size or even exceeding Jupiter. And they are all very, very close to their stars. So close that a year on them lasts only a few days or even hours. Indeed, there are exceptions. For example, the planet Dagon near the star Fomalhaut, which is 25 light-years away from us. It has dimensions comparable to Earth, but it is located on average 110 astronomical units away from its star, which in terms of our solar system is 4 times further than Neptune. Its year lasts more than 7,000 years. Or here's another exception, the TRAPPIST-1 planetary system, 39 whole light-years away from us. They found as many as 7 planets around it, and all of them are comparable in size to Earth. That is, 5 of them are practically the same as Earth, and the remaining 2 are slightly smaller. But the similarity ends there. They are all located very close to the star. Their year lasts from 1.5 to 18 days, and the star TRAPPIST itself is not very standard. In terms of size, it is almost exactly the same as Jupiter, but perhaps a little bit larger, the smallest amount. But its density, according to official data, is as much as 50 times greater than the density of the Sun. And knowing that the density of our Sun is a whole 3 grams per cubic centimeter, we understand that the density of the substance of the star TRAPPIST, 1 is as much as 155 grams per cubic centimeter. For understanding the densest substance in our solar system is osmium, its density is 22 whole and 6/10 grams. That is, most likely, this star is a core left over after a supernova explosion. But I won't argue with astronomers here. I'm leading to something else. Almost all of these planets were discovered by the transit method. That is, the idea is that when a planet passes between us and the star during observation, it slightly obscures the star, as a result of which its brightness falls by some negligible amount. And then when the planet passes, it recovers. This method has one huge and obvious downside. Thus, you can only detect planets that are quite large and close to the star, which allows you to accurately identify the planet and its rotation speed around the star. What we are actually observing is a whole wagon of new planets being discovered in this way, and almost all of them are huge and very close to the stars. We simply do not see others in this way. Besides, these could be not planets. Well, if we take our Sun as an example, which also, by the way, rotates quite quickly and on which there are the well-known sunspots, then an astronomer armed with such a transit method at a distance of several light years could quite decide that sunspots on the Sun are the passage of massive planets. Yes, there are other ways to detect planets. For example, the radial velocity method, gravitational lensing, and even direct visual observation. However, firstly, they are all based only on hypothetical assumptions about objects causing this or that phenomenon. And secondly, 90% of discoveries are made precisely with the help of the transit method. And thirdly, no one will wait several years or even decades to capture the transit of a planet at a great distance from the star, and then wait just as long and just as long again to confirm the data. That's why we only see supermassive planets and only directly near stars. Well, as we see it. And we've only observed a few unique exceptions live, for example, with the help of the Hubble telescope. This is the same planet Dagon at a distance of 100 astronomical units from Fomalhaut. How did they spot it and distinguish it from others at such a distance, if in our own solar system, at such a distance, we can hardly see anything? Well, never mind, let the astronomers explain. I told all this in order to understand our solar system better. So,
In the beginning, there was
the word no, not so far. Let's get closer. And God created the earth. Stop. Now too close. Let's go a little earlier. And let's start, perhaps, after all, with the classic version. 4 whole 5/10 of a billion years ago, a quiet and peaceful interstellar gas and dust cloud began to collapse. That is, to shrink. The randomly formed mass center began to gradually attract individual molecules to itself, then entire clouds of matter. And increasing in size and mass, it swallowed more and more gas, until its mass reached a critical point and a new star, our sun, was ignited. However, during the collapse, curious phenomena occurred. Firstly, the entire cloud received a rotational impulse, meaning everything inside began to rotate in one direction around the common center of mass. Secondly, as the rotation continued, other centers of mass formed. Smaller and, having received their share of matter, they gradually occupied their current orbits and received the name of planets. In such a simple way, the rules of movement of objects in the solar system were born. Remember this simple scheme. It will come in handy in the following videos more than once. For now, let's look at the graph of the distribution of planet distances from the Sun. It clearly shows that the first 4 planets are placed quite evenly and then with approximately the same interval through a third of the astronomical unit. For understanding, 1 astronomical unit is the distance from Earth to the Sun. That is approximately 150 million kilometers. Therefore, a third of an astronomical unit equals 50 million kilometers, plus minus. So, Mercury is on average 0.38 astronomical units away, Venus 0.72 astronomical units, and Earth correspondingly 1 astronomical unit. And Mars is 1.54. That is, as we see, the step between the planets is approximately equal. That is approximately 50-60 million kilometers. However, on Mars, this sequence ends, and then there is a huge gap of 3 whole 5 astronomical units, filled with an asteroid belt, and then comes Jupiter. From this moment, the clear step of the sequence is disrupted, and each subsequent planet is located further and further away. For example, from Jupiter to Saturn is already 5.5 astronomical units. From Saturn to Uranus is more than 10. And from Uranus to Neptune is 21 astronomical units. Next begins the so-called Kuiper Belt, the second outer asteroid belt, which contains a huge number of small planetoids, among which is Pluto. Now let's look at the graph of mass distribution across the planets. To understand what exactly we see on the graph, let's recall the classic version of the birth of planets. In the beginning, there was a single protoplanetary gas dust disk in which mass centers began to form. And they, in turn, began to attract matter to themselves more and more strongly, gathering into planets like a snowball. But at the same time, they were already moving along their orbits with a certain step between each other. In this way, you can calculate the amount of matter that each planet was able to gather. Let's start with the Earth as a basis. Let's assume that its entire path around the Sun, which is about 942 million kilometers, allowed it to gather its current mass, which we will take as a unit. So, Venus, whose path is less than 678 million kilometers, should gather less matter. That is 72% of the Earth's mass, in fact 81% of the Earth's. It doesn't quite match, but overall it seems to be true. Mercury's orbit takes up 360 million kilometers, which is 38% of the Earth's, and therefore its mass should be accordingly. However, its mass is only 5%. Moreover, its orbit is very elongated, almost 15 million kilometers. In connection with these facts, there is a popular version that Mercury is not a planet at all, but an object accidentally captured by the Sun's gravity. Well, for example, a former satellite of Venus. Now let's look at Jupiter. Its path is 4,850 million kilometers. That is 514% of the Earth's path, plus the path itself is 10 times wider. That is, even the roughest estimate gives an expected mass 6 to 70 times greater than Earth's. However, in reality, Jupiter's mass exceeds Earth's by 320 times. Where did all this extra mass come from? Next in line is Saturn, and everything is normal with it. Considering its distance at 95 astronomical units, its mass exceeds Earth's by 95 times, which fits perfectly into the general theory. So, we have three planets, Venus, Earth, and Saturn, which could have formed simultaneously with the solar system from one protoplanetary disk. Plus Mercury, which by all accounts was captured by the Sun, and Jupiter, which strangely received a huge amount of excess mass from an unknown source. And what about Mars? Mars doesn't fit into the general schedule at all. Judging by its distance from the Sun, its mass should be 1 3/10 of the Earth's, or even 1.5. However, instead it only has 10% of the Earth's mass, which is only twice as much as Mercury's. In addition, its orbit is also stretched out nearly 50 million kilometers, which also speaks to its unnatural position. A massive scar runs across the planet from a probable collision with another massive celestial body. Moreover, this body did not merge with Mars into one planet, but continued to travel on its own further. What can this say, for example, about its enormous size comparable to Mars or even larger? And two clear fragments from that catastrophe, Phobos and Deimos, are whirling around Mars's orbit. So Mars is clearly not in its place. If it had formed simultaneously with the solar system, its place would have been somewhere around Mercury's orbit, or as a satellite of another planet, with a mass of 1 whole and 3/10 of the Earth's mass, and located on the inner edge of the asteroid belt. How then did Mars end up where it is now? How did the Sun snatch Mercury from Venus, if Venus had it at all? Where did Jupiter get so much extra mass? How did his famous temple appear on Mars in the Mariner Valley? And where did the object that brought it go? There is a separate theory for each of these questions. However, thanks to the presumed age of our solar system at 4.5 billion years, all these events are spread out in time as they see fit. No one wants to combine these and other puzzles into one catastrophic event. However, remember our simulation of 3 moons orbiting the Earth. Remember how it all ended? The outer moon began to eject the remaining moons from the inner radius and collided with some of them, increasing its mass at their expense. It worked simultaneously as a vacuum cleaner and a catapult, which pulled everything from the inner part of its orbit as far as it could reach. The majority of lunar seas are the result of collisions with massive objects, mostly on the inner side facing the Earth, and the subsequent angular momentum of these objects turn them into mass cons under the surface of the moon. So Jupiter most likely played the role of such a moon, only on a much larger scale in our solar system. At some point, it began to pull everything that could be pulled from the inner radius. The width of this radius is clearly visible. It's 4 astronomical units on each side. It swallowed up most of the objects, hence its excess mass. Some part was simply thrown out, and some objects didn't reach it and stabilize on arbitrary orbits. Thus was formed the search for asteroids and Mars, which can boldly be considered not a planet, but only the first and largest asteroid. In such a roundabout way, we have come close to the mystery of the miraculous catastrophe that occurred in our solar system some time ago. In this video, I didn't give a full answer to all the questions, but this is not my last video. I hope. Friends, none of us are afraid of mistakes, and if you see a flaw in my logic, don't hesitate to leave a clear, literate, and unambiguous comment under the video.